Good evening. Now we will see next four questions of assignment 4 of NPTEL. So find the slope at point B. Now we know slope we are going to get, that means we have reaction at B. So whatever reaction at B we have, that will be slope at B. Reaction at A, we have slope at A. So we have, this will be given beam. So we have 4 kilonewton per meter. We have this distance 2 meter. So reactions we will get as 4 meters, 4 kilonewtons. Now reactions we have slope that is of conjugate beam, not of simple beam. So we have, this will be M by EI diagram. W value we have 4, L we have 2 square upon 8. So we have 16 upon 8. So that will be 2 upon EI. Now conjugate beam, so we have as it is, and here we have conjugate beam with loading. And we are now interested to find value of VA and value of VB. So more we are interested with slope at A, so that is B. So we are interested with reaction at B. So now we can have VA equal to VB equal to total load by 2. Now what is total load? So we have this as parabola. So we have 1 by 2 into, already we have seen this, 2 by 3 into base we have, that is 2 meter, into we have 2 upon EI. Now if we will see this, so this 2 gets cancelled and we have this value as 4 upon 3 EI. So we have 4 upon 3 EI. So 4 upon 3 EI, we have option that is B. So that is theta B. So we have, this will be theta B, which is 4 upon 3 EI. Now if we will go for this, so already we know, if I will draw conjugate beam with M by EI diagram, then we are going to be in this fashion. And we have this as clockwise, so it will act upward. And the value we have, that is 50 kilonewton per meter. Sorry, kilonewton meter. So we have this as M by EI diagram. So we have this as 50 upon EI. EI we have constant. We have to find deflection at C. This is 4 meter. So we have to consider only portion of this and we have to find moment at C. So how we will get moment at C? So we will have this as rectangle. So I will go with rectangle 50 upon EI into 4 into what is centroid of this? So we have this centroid will be 2 meters. So into 2, and then from this we will get 50 for 2000. So 4000 upon EI. Now we know EI is given. So if I will multiply EI, then we have 200 GPA is given. So into 10 raised to 3 into 100 into 10 raised to 6. So this becomes 2 into 6 plus 3, 9 plus 4, 13. This will be Newton millimeter square. Convert it into kilonewton meter square. So 13. So this becomes 2 into 10 raised to 13 into 10 raised to minus 9. So it becomes 2 into 10 raised to 4, or I can write it as 20 into 10 raised to 3. Unit is kilonewton meter square. Now we will get MC as delta C, and then delta C we have 400 divided by 20 into 10 raised to 3. Now this value is in meter. To convert it into millimeters, we have to multiply it by 10 raised to 3 again. So into 10 raised to 3, now it is millimeter. This gets cancelled. 0 gets cancelled. And we have this value equal to 20 millimeters. Now we need not require to calculate theta b because 20 option we have one only. But we can calculate theta b, that is equal to VB. So we have this VB. VB will be total area. So what will be total area? 50 upon EI into 6. So we have 300 upon EI. Now what is value of EI? 20 into 10 raised to 3. So we will get it as, sorry, this is 50 into 6. Yes, 300 upon EI. And then we have 300 divided by 20 into 10 raised to 3. So now we will get this gets cancelled, and then we have this will be 15 upon 10 raised to 3. So this will be 0.015 radians. So we got both answers. So 20 millimeter and 0.015 radians. So this is sixth problem. Then we have seventh. Now in this again we have to go with conjugate beam. So B becomes fixed, and then we are loading till this portion. So we have loading diagram will be in this fashion. What will be load? So we have total load. We have this will be 12 into 2, that is 24. Act at 1 meter. So we have this will be 24 kilonewton per meter. Now we are interested to find deflection at deflection at B. So we have to find value of MB. So now total load of this, so that is actually in upward direction. So total load we will get, that will be equal to 1/3 of base we have 2 into 24. So it becomes 16 upon EI. So this is 24 upon EI. And where it will act, so this will act of 3 by 4 into 2. So this will be 1.5 meters from C, and we have that is from B. So this is 1.5 plus 2, so that is 3.5 meter. And therefore we will get delta B equal to MB, and that is equal to 16 upon EI into, we have 3.5. And then we will get it as 16 8s of 48 plus 8. So 56 upon EI. So this is actually not correct. So we have option, that is A, 56 upon EI. And then we will go with last in this. So now again we are in the same fashion. We will draw conjugate beam, and then if we will draw bending moment diagram, so we have 20 into 5, so we have 125. This is M diagram. So that is actually, if it is bending moment diagram downward, you have to show an arrow upward in conjugate beam. Now we have 2 EI till B. So value at B we have 50. So here in this portion, from this to this, we have to divide by 2 EI. And in this portion, we have to divide by EI. So now conjugate beam with M by EI diagram, how we will get this? So we will divide this 125 by 2. So it becomes 62.5. Now this 50 we will divide by 2. So it becomes 25. And then again for second portion, that is for BC, it is 50. Here we have 25 and then 0. So we are being with 3 parts. So if I will take this on this side at a large portion, then first part I will take it as, so we have 2 portions I will consider of this. So we have, this will be first portion 25 upon EI, and this will be remaining portion which will be 37.5 upon EI. Now first for this, we have total load, I will consider this 25 into 3 upon EI. So we have this value, that is equal to 75 upon EI. So this value we have 75 upon EI. And distance from B, so we have this will be 1.5 meter. Now second we have this portion. Now we have 1/2, base we have 3 into 37.5. And if we will calculate this value, then we have this value 37.5 into 1.5. So it comes 56.25. Now it will be this distance 2/3 of 3. So this will be 2/3 of 3. So this becomes 2 meters from here. So 1.5 meter from B. This is 2 meter from B. And then we have this triangle which will be 1/2 into 50 upon EI into 2. So this will be 50 upon EI. And where it will act at 2/3 of 2 from C. So that is 4/3 from C. So it's CG 4/3 from C. Then it's CG 1.5 plus 2 from C. So that will be 3.5 meter from C. Moment we have to take at C because deflection we have to find at C. And this is also 2 plus 2, that is 4 meter from C. And therefore, we will get delta at C equal to moment at C. Due to this 25 rectangular portion, we have 75 upon EI into 3.5 plus 56.25 into 4. This is upon EI plus we have 50 upon EI into 4/3. And if we will calculate this value, then we have this value 75 into 3.5 plus 56.25 into 4 plus 200 divided by 3. And this comes 554.17 upon EI. Now EI is given, so we can have EI that is equal to 250 into 10 raised to 3 into 200 into 10 raised to 6. So we can have 550 into 6 and 612. And then if we convert it into kilonewton meter square, so into 10 raised to minus 9, this is Newton millimeter square. And then this will be 50 into 10 raised to 3, that is kilonewton meter square. And if we will put this, so we have this will be 554.17 upon 50 into 10 raised to 3. This is in meters. And then if we will have 554.17 into 10 raised to 3 divided by 50 into 10 raised to 3, then this value is in millimeters. And we will have this value that is 11.08 millimeters. And we have this will be option is D, 11.08 millimeters. So remaining two we will see tomorrow. Now we will stop here only. Thank you. So you have to divide this into 3 parts and then you will get answer for it. So thank you. We will stop here only.